is the number that's underneath the radical sign in the quadratic formula. And the purpose of a discriminant is to determine the number of solutions you are going to have. Okay? So sometimes it's nice to find the discriminant first to determine whether you're going to have just one solution, two solutions, or no real solutions. Go ahead. So if we have the discriminant is positive, so if b squared minus 4ac is a positive number, what type of solutions are we going to have? Two real solutions. What does that look like graphically? Two x-intercepts. Good.
Yeah. Couldn't think of a word.
If your b squared minus 4ac is equal to 0, what type of solutions are you going to have? Good. One real solution. And what would that look like graphically?
Touches the vertex is...
The vertex is the x-intercept. And if b squared minus 4ac is negative, then what type of solutions are we going to have?
Two imaginary.
We're going to have 0 real solutions, but means we'll have 2 imaginary solutions. What would that look like graphically? No x-intercepts. So your parabola is kind of up there in space. Okay? Do we need to practice determining what your discriminant is?
Why can't it just be 0 instead of 2 imaginary?
Well, so it's 0 real solutions, which means that we're going to have 2 imaginary solutions. We need to start thinking about imaginary numbers in our minds.
But if they're imaginary, why do we have...
Because in math, you need to be able to explain every single thing out there in the world. So if you're not real, what are you? You need to be something. So it's imaginary. Mathematicians need an explanation for everything in the world. Because you need to have something to explain everything.
You know, sometimes things don't...
All right, so...
Or explain this binder mathematically.
Well, it would have a volume. It would have a surface area.
Yeah, let's go. You got all these little ridges. Got it. You gotta get it.
You good, Cole?
Wait. I have one more.
So can I bypass doing the b squared minus 4ac? Because you guys did that yesterday. Good. Because I'm going to bypass that. If you don't know how to do it, relook at it later on. All right. So now let's get into the world of imaginary numbers. Oh, I had to wear my pin. Put my pin on really quickly. So your imaginary numbers come up when you have a number. One year I made these pins for all of my students in Algebra 2. They don't have button machines here at Marshwood.
I would wear a pin.
People are selling them on the black market, I'm telling you. Okay, this is my imaginary pin.
Isn't that a radical?
It is.
I have a pin, but it says free hug.
Okay. Good. So, an imaginary number is a number whose square is less than 0. So now let's think about that. If you square 2, you get what? 4. Is that less than 0? No. If you square 9, you get 81. Is that less than 0? No. So any square whose number is a positive number or 0 is a real number. But if you had a square where your square was less than 0, making it negative, then it becomes an imaginary number. Okay? So, This is what we need to think about when dealing with imaginary numbers. Don't even write that page. Let's just do this. Do this. This is the most important part about imaginary numbers. Make a star. If you take the square root of -1, it's going to be equal to 1i. And we use that I to, and I just kind of put a tail on it to italicize it. That I represents an imaginary number.
It's like a reverse J.
It looks like a reverse J, yeah. If I had the square root of -4, well, what's the square root of 4? 2. But since it's a negative, I'm going to say that it is 2i. So we're not making life complicated. All we're doing is just popping an I out of our square root.
Why do you have to put an I?
Just pop it out.
Wait, why do you have to put an I?
Because it's a negative, I can't take the square root of a negative number.
Stands for imaginary.
So that means it's going to be an imaginary solution.
Noise.
So the square root of -16 would be what?
Don't you dare make it even more complicated.
It would be 4i.
Yeah. Ooh, don't you get
Called out. You wait.
What about the square root of -17? What would that look like?
something point something I?
Pop the I out.
Ooh.
Pop it out.
It'd be 4 point.
And it would be
Oh, shoot, you're-
I square root 17.
Oh.
That's it.
Oh. I was gonna
Whoa.
show you the part.
Why is there another square root of 100?
Oh, are you?
I times the square root of 17. Because really, think about this. Think about this. The square root of -17, isn't that the same as the square root of -1 times the square root of 17?
Oh.
And didn't we say the square root of -1 was 1i?
No.
So it'd be I square root 17.
So it matters what side it's on?
Your I will always go in front of the radical sign.
Okay.
Okay? Yeah, so get it? What does my pin say? I heart math. Yeah, I forgot I was going to put it on at the beginning of the period. I just put it on. There was one year I made these for all of my students. If we had a button machine here, I would do the same for you guys.
Your last school had a button machine.
We did have a button machine.
Why?
Well, that's for like vote for Patty.
The home ec class had button over at Trape. They had a button machine. Yeah. Trape has a button machine, and you guys don't. That's like the one thing you guys don't have. All right, let's practice this one. The square root of -20 would be what?
It would be I square root of 1.
I square root 20. Now let's practice simplifying that square root of 20. How would you simplify the square root of 20? So 4 times 5, what's the square root of 4? 2. So it would be really 2i square root 5, right? Okay, so this is the only thing we're going to add to what we've been doing so far is popping out an I in our radical. So when we go to solve our quadratic equations, in the past, when we get a negative underneath the radical sign, we would just write no real solution. Well, now we can go further than that. I can actually find 2 imaginary solutions. And I'm just going to do exactly what I did, whether we did it by solving using square roots. You can't factor imaginary answers, so that doesn't work out. Or the quadratic formula, or completing the square. So we're going to keep practicing those same methods. It's just now our answers might have a negative underneath the radical sign. And now all we're going to need to do is rewrite our answers with an I in it. Okay? So processes are not changing. It's just the way your answer looks is going to be different. So we already went through all of these. So let's go ahead and do some solving. 4x squared plus 100 equals 0. If I want to solve that using square roots, why can I solve this using square roots?
They're both square roots. They're perfect square
Well,
roots.
that's nice, but they don't necessarily need to be.
Right.
My b in this case is what?
0.
0. And because my b is 0, we can use the method of solving using square roots, right?
Okay.
So that means I need to get the x squared by itself. So what's my first thing I'm going to do? Subtract the 100 over. Then divide by 4. So now I get x squared is equal to negative 100 over 4, which is negative 25. How do you undo a square? Square root both sides. In the past, we would write, no real solution, I'm done. But the square root of negative 25 is 5i. What must we remember in our answer? Plus or minus, because remember we said we have 2 imaginary solutions when the number underneath the radical sign is negative. Okay? Okay, move on. Yes.
Wait, is this less than 5.6?
Yes. 5.6 started yesterday with the discriminant, continuing with this, and then we'll continue tomorrow. We're stretching into 3 days. Well, we need to figure out what method we're going to use. They're suggesting we use completing the square, so why don't we go for it? It's not bad. My b is an even number. I don't have an a other than 1, so it shouldn't be too bad. So completing the square, what am I going to do? So x squared minus 8x plus blank equals negative 36 plus blank. What goes in the blank? 16. What does the left side factor to? X minus 4 squared equals negative 20. Good. Next move. Square root both sides. Okay, we did this one. X minus 4 is equal to plus or minus I square root 20. Just for fun, what do we say we simplified that to? 4 and 5, so it was 2I square root 5. Yep, move that negative 4 over, which is going to make it become a positive 4. I know I did a lot in that step. I moved the 4 over. I simplified the square root of 20 to 2 square roots of 5. And there it is. Done and done. Yes. I'll be content right now if you just do the square root of 20. So if you would leave it as 4 plus or minus I square root 20, we'll be okay. Eventually you are going to have to simplify that. So if you want to start practicing it, start practicing it. Okay, questions with that? See, that was an easy completing the square. Let's do a quadratic formula. Two x squared minus 6x. This is the last one I have for you. Minus 7. Are we going to move everything to the left or move everything to the right? Yeah, move everything to the left because your x squared is positive. So 2x squared plus 6x plus 7 is equal to 0. X equals negative d plus or minus radical b squared minus 4ac all over 2 times my a is 4. Okay, calculator work. Let's find that discriminant. 36 minus 4 times 2 times 7 is negative 20. That's convenient. That's what we just had in the last one. What does the square root of negative 20 simplify to?
2I square root 5.
Yep, can we just say that? So negative 6 plus or minus 2I square root 5 over 4. We can go even further. Think about separating this. So ignoring this side, what does negative 6 over 4 reduce to? Good, so we have negative 3 halves plus or minus. Ignoring that part, what does 2 over 4 reduce to? 1/2. So 1I square root 5 over 2. You can either leave it separated or together. That's up to you. There's your answer.
Want us to do that?
You should. You should, if you can, you simplify that. Because eventually we need to get there. Right now, I just want you guys to get in the process of popping the I out. Okay? So, it's the only thing that we have now added. And this is called a complex solution, hence the title of our chapter. And a complex solution is a solution that has a real part and an imaginary part. And you always write the real part first with the imaginary part second. Questions? Got it? All right.